Okay, I am going to include this a podcast from based on a paper that came out that looks at the various frameworks used for assessing the drivers of human stress on the environment. We have talked about this model in another context already, the so-called IPAT equation that came from John Holdren and Paul Ulrich in the 1960s, and of course it's a very limited kind of idea. So the IPAT equation, so-called IPAT equation, impact is population times affluence, which is consumption per person, times technology, which is impact on the environment per unit of consumption. So it kind of clubs everything to this into this technology part, and we have already seen that population has grown super exponentially, but it's the consumption and affluence that have been driving the impacts. So the IPAT equation is a widely used simplification of the factors causing environmental degradation. The equation I equal to P times A times T is short for the environmental impact equal to population times affluence, which is consumption per person, and technology, which is impact per unit of consumption, or how technology allows us to consume at higher and higher rates. And of course, in the 21st century, we want technology to drive us towards decarbonization, net zero, efficiencies, reduced emissions, and so on. It's crucial to remember, though, that the three factors are intermediate causes and not root causes. Population has grown because of various factors of high fertility that was related to high infant mortality and short lifespan, but lifespan has been extended, infant mortality has been reduced, and consumption per person has scales and contexts which have to be considered, as well as this kind of a clubbing of all the impacts per unit of consumption into one term is problematic. So now there are newer models for the 21st century, as this review argues, the so-called StripPAT. This is a model that expands on the IPAT model and adds some parameters. It's the model that was developed to remedy the limits of IPAT while capturing its strengths. The name means alternatively strip of IPAT, or stochastic impacts by regression on population, affluence, and technology, and it has a stochastic error term I added on top of all these exponentials to each of the population, affluence, and technology, with a constant in front of it. Obviously, these are kind of diagnostic models where given, let's say, population and affluence, and let's say technology impact can be driven, or if impact is known, then you can derive technology, which is a driver of that particular stressor on the environment. Okay. The other model is called DPSIR, Driving Forces, Pressures, States, Impacts, and Responses Framework. This is the paper from which this schematic is adopted for this review paper that we are looking at. So here are the drivers, causes of stress on, let's say, aquatic ecosystems, and the pressures include things like pollutants, which drives the state like water quality, and then the impacts such as human and ecosystem health, which feeds to the responses in terms of policy standards, and then feeds back on the impact, hopefully reducing the impact. And responses also try to address things like the state and the pressures. Environmental regulations try to monitor water quality and regulate pollutants, for example, and those are expected to drive down the negative drivers of human impact on the environment. There is the larger scale Millennium Ecosystem Assessment Framework, which also looks at drivers, ecosystem services, and human well-being. This happened, it was a heavily funded effort, and there was an attempt to have a follow-up effort, but it costs a lot of money. I think it cost, the Millennium Ecosystem Assessment cost something like $600 million. Obviously, doing it again would require large funding, which I think hasn't been approved as yet, as far as I know, but you can check it. So here we are in the global framework where global warming, global governance issues, and global pollutants like well-mixed greenhouse gases are responsible. So there is a short-term and long-term time scale involved there as well, and ecosystem responses depend on the time scales, and how quickly some species can respond depends on how quickly the environment is changing, whether it's temperature, precipitation, humidity, or vegetation, habitats, and so on and so forth. Under that you have regional and local assessments, and you also have strategies and interventions. Okay, so human well-being and poverty reduction, you can see this symbol here relating each one in terms of strategies and interventions. Basic material for a good life, health, good social relations, security, freedom of choice and action. They are put in this box here. Indirect drivers of change include demographics, or population, economics, or globalization, trade, markets, policy frameworks, socio-political. We have things like Ukrainian invasion of Ukraine by Russia is affecting water quality and air quality and erosion on the Gulf Coast of the US, because the US government wants to help Europe by supplying more gas and so on to compensate for sanctions on Russia and to isolate Russia. So all those things are indirect drivers of change, and they are not local always, they can be remote. Science and technology, cultural and religious. Ecosystem services is a terminology that's used. It depends on life on Earth and biodiversity. All intuitive concepts, and yet it's not always easy to pay for the ecosystem services, which include things like provisioning, regulating, cultural, and supporting. And there are direct drivers of change, which are interacting with indirect drivers, and all of them feed back to human well-being and poverty reduction, and hopefully there is the strategies and interventions that reduce the impacts directly and indirectly. So direct drivers of change include changes in local land use and cover, species introduction or removal, intentional or unintentional, technology adaptation and use, external inputs like fertilizers, pest control, irrigation, harvest and resource consumption, climate change, natural, physical, and biological drivers. Right? So the other framework is this one, telecoupled human and natural systems of the Wulong Nature Conserve. Eleanor Ostrom, who died a few years ago, but before that she had won the Nobel Prize for her incredible work on how to manage shared resources in continents like Europe, came up with many of the ideas for this kind of framework, the so-called CHANS coupled human and natural systems. So you have this is the Wulong nature reserves coming from here, and there are agricultural products, information, and pandas involved, and of course you have interactions in terms of human natural systems via tourists, conservation subsidies, and industrial products being extracted, right? What Eleanor Ostrom's work did was to add a socio-ecological systems framework to this coupled human-natural interactions, social, economic, and political settings in which these things happen provide a context for how the system should work together to monitor resource units, look at resource system, develop governance system that avoids the tragedies of the commons and takes care of the users. So you have interactions between all of them and outcomes, and the local system then interacts with the related ecosystem. So eventually you go from one reserve to the regional scale, local scale to regional scale, and global scale, as we said before in the millennium ecosystem assessment. Okay, approximate hierarchy of scales of analysis for ecological and for social systems here includes the ecological systems in terms of biosphere, biotic province, landscape, watershed, airshed, community, population, down to individuals. And the social systems have the global system and the individual at two ends, with households to political subdivisions and nations, and of course communities and cultures, with each one feeding back to each other. And this whole social system is placed within the ecological system. Often people think of as humans and environment and sustainability, but ideas from people like Herman Daly were that we have to think of ourselves as placed within the environment, and everything has to be taken together to worry about the resources we are using that are renewable, resources that we are using that are not renewable, and how we pollute these things, and so on and so forth. So the summary from this paper that I'll just read off, since this is just a brief introduction, it's good to know what points were being made. The massive transformations in the environment being brought about by human actions makes imperative an understanding of what drives those changes. So what are the human drivers? 6 major frameworks have emerged to specify how human actions drive increased pressure on the environment. The frameworks use somewhat different terms for the variables involved in human-environment interactions, but are largely compatible, as we saw with some schematics. Analysis of human drivers of environmental change have been conducted at levels ranging from individual to the global. Although most analyses are conducted at one level, it is critical to keep in mind that more micro levels, i.e. individuals and households, are embedded in larger levels, i.e. regions and nations. We lack the ideal data sets for understanding human action in this context. This is very critical, especially for health, impacts of humans on the environment, environmental degradation, and health, water quality, air quality. Such data is never really available at the time and space scales, spatial and temporal scales needed. In the absence of such data, our most robust understanding comes from synthesizing across studies done in different places at different times and different scales with different limitations. In fact, 4 empirical research traditions that, have examined the human drivers: macro comparative analysis of differences across nations, studies of household energy consumption, land change science, and research on the commons, which are shared resources. Atmosphere is one, oceans, there can be often forests, land, pastures, agricultural ecosystems, land, and so on. Each of the empirical traditions has developed a set of general findings, but there is relatively little integration across the traditions. These research traditions are usually not very well connected in terms of integrating the findings, and usually it's not also very clear if the solutions that work in one place are transferable to another place. So the typology of these managing resources in such frameworks is of social, economic, and political settings is not always very clear. But nonetheless, the drivers of human impact on the environment must be understood and quantified, and risks identified so that the systems can be protected, managed, and reinvigorated, and so on. So many such studies exist, but I just wanted to include this as a podcast to give you a sense of the various frameworks used for such assessments of human impact on the environment, which is obviously much more critical now in the 21st century in terms of making sure that everything we do remains consistent with net zero and the global warming targets as well.